Hello everyone, welcome back to Life with Technologies YouTube channel, and thank you for watching and supporting us. So if you are watching and you are yet to subscribe, kindly hit that subscribe button to stay tuned for more upcoming videos and also to support our channel. So this is a continuation of our Huawei Lab simulation series, and remember in this series we discuss how to implement or how to configure different networking technologies or networking protocols on Huawei routing and switching devices. So in our previous episode, we have discussed how to implement protocols like OSPF, ISIS, BGP, BGP MPLS, VPN, and many other applications on Huawei routing and switching devices. So if you haven't watched those videos, you can check them on our channel. In today's episode, we'll be focusing on how to implement Pseudowire or nodes in different IGP domains. So remember in our previous episode, we have mentioned that the service provider network is always segmented into different IGP domains. So we have different SIS processes running on our network, and you need to deploy a layer 2 VPN on top of it. So this is what we'll be focusing on in this episode, and in our previous episode we have also discussed how to implement a Pseudowire in the same IGP domain. So if you haven't watched it, you can check it on our channel. So we have the topology setup. We have C1 and C2 will be simulating customer equipment. And then we have our MPLS backbone. So in our MPLS backbone, it's divided into two IGP processes. We have ISIS 20. This one should be ISIS 20. And we also have ISIS 10. So ISIS 20 has R4 and R3. And then we have R1, R2, and R3 in ISIS 10. And for the e-pipe or the Pseudowire, we'll be configuring our e-pipe to start from R2, R1 facing C1, and go all the way to R4 facing C2. So you can see that we are spanning or we are traversing two different IGP domains. We have ISIS 10 and we have ISIS 20. So our e-pipe or our layer 2 VPN will be running on top of the two ISIS processes. So we know that one advantage of Layer 2 VPN, especially when we are deploying the enterprise services, it allows us to carry services for multiple customers on our MPLS backbone. So we can have another customer here, we can have another customer here. We'll deploy services for them just on our same MPLS backbone. We don't need to deploy a different network for different customers. So this one allows for scalability of the service provider network in managing many enterprise customers. So C1 and C2, they are our customer sites. We'll be simulating how we can communicate from C1 to C2 via our MPLS backbone network. So before we deploy layer 2 VPNs on our network, we always have to do some basic configurations. So as you can see, we have IGP plan to be deployed on this network. We also need to deploy MPLS and MPLS LDP for the signaling. So you need to configure the interface IPs, you need to configure ISIS protocol to ensure we have reachability, and you also need to configure MPLS and MPLS LDP on the network. So again, if you are watching and you are yet to subscribe, just remember to hit that subscribe button. You can like the video, you can share with your friends, and if you have any comment, you can leave it in our comment section. So for the configuration steps, we have several configuration steps that we need to follow. I've mentioned that we need to do ISIS configuration, MPLS, MPLS LDP, and we also need to enable layer 2 VPN, the MPLS L2 VPN on our network, because an e-pipe or a Pseudowire, it's a layer 2 VPN. So we need to enable it before we can be able to configure layer 2 VPNs on the network. So this is the topology in ENSP, as you have seen on the PDF, same setup, R1, R2. This is in ISIS 20. And then this is ISIS 10. And the IP address assigned are also indicated on the topology. So the first step of our configuration will be to configure IP address on interfaces and enable SIS, MPLS, and MPLS LDP and layer 2 VPN in the MPLS backbone. So we are starting with R1. You can see the first step is always to configure the sysname, a good practice to ensure that anyone logging into this router will be able to identify it based on the sysname. And then we have MPLS LSR ID. So before we configure MPLS, we always have to configure the LSR ID. And in this case, we are using loopback 0 as our MPLS LSR ID. And then we enable MPLS, we enable MPLS L2VPN, we enable MPLS LDP. And then IGP configuration, we have ISIS 10. So these are the ISIS configuration, process 10, level we are all configuring all routers in level 2. And then core style is set to wide, the network entities generated from loopback 0 IP address, and the IS name for ease identification of this ISIS session. So once we have finished configuring MPLS and ISIS on our router, we need to go ahead and now configure the interfaces. So we are configuring interface loopback 0, enabling ISIS on it. And the final stage is now to configure the physical interfaces. So these are the physical interface configuration. We assign IP address, we enable ISIS on the interface, we enable MPLS, we enable MPLS LDP. So in case you forget to enable MPLS and MPLS LDP on any of these interfaces in our MPLS backbone, the layer 2 VPN will fail to come up. So at this stage, I will log into R1. First, I need to copy these configurations. So these are the configurations for R1. I'll copy the configurations and we'll do the configuration step by step because nothing is configured on the routers. So I'll copy and then log into R1. Just open all the CLIs. Have R1 here. I'll clear. So I will undo terminal monitor just to disable the debug messages. Then system view and paste the configurations. That is for R1. Then R2 we do the same. Configure system name, configure MPLS, configure ISIS, and enable it on the 3 interface. Those are the 2 interface connecting the directly connected routers. So I log into R2, system view, paste the configurations, quit, let me undo terminal monitor. So we have finished configuring R2, we'll configure R3. So for R3, we are also configuring the sysname, enabling MPLS, MPLS LDP, MPLS L2VPN. And for ISIS configuration, we are configuring 2 ISIS processes, ISIS 10 and ISIS 20. Remember that is the boundary for our different IGP domains. So we need to configure the 2 ISIS processes on R3 and enable it on the respective interfaces. So these are the configurations. Need to copy out the sysname. And for us to be able to communicate between the different nodes, we are also doing the route import between ISIS 10 and ISIS 20. We are just doing it simple, but in a production network, you always have to use route policies to control what is imported between the different IGP processes. So on R3, undo terminal monitor, system view, and paste the configurations. And finally, we'll do the configurations for R4. So same, system name, MPLS LSR ID, MPLS L2VPN, MPLS LDP, and then we do ISIS and interface configurations. So on R4, undo terminal monitor, system view, paste Quit. So we have finished configurations for the basic configs on the routers R1, R2, R3, and R4. So we can verify our IGP status, display ISIS peer. You can see that these are appearing to R. I need to change the IS name for this router. So I will do ISIS 10, display this, I change the IS name to R2. So if I rerun the same command, display ISIS peer, you can see that we have one ISIS peering session with R2. On R2, we expect two ISIS processes, display ISIS, two ISIS session. We have one to R1 and another one to R3. On R3, we also expect the same, display ISIS peer. We have one peering session to R2 and one to R4. I need to change the IS name, display, so this is ISIS 20, display this, IS name is set to R4. Display ISIS peer, so we have a peering session to R3. On R3, display ISIS peer, we have one to R2 in ISIS 10 and one to R4 in ISIS 20. So we can test our reachability. We can try to ping 3.3. We are able to ping. Ping 2.2, we are able to ping. And then ping 4.4, we are able to ping. So we have connectivity in our network. So we'll move to the next stage of our configurations. So step 2 will be to configure MPLS LDP remote peering session between R1, R3, R3, and R4. So remember, we only have the local sessions. If I log into R1, if I display MPLS LDP session, you can see that we only have a local session to the R2 router. On R2, we expect display MPLS LDP session. We only have two local session to the connected routers. On R3, display MPLS LDP session. We also have two sessions. On R4, we expect one session, display MPLS LDP session. We have one peering session to 3.3.3.3. So the next stage of configuration is to configure LDP sessions, remote LDP sessions. So we'll start with R1. So the command is MPLS LDP remote peer, and then this can be a string. This is just a name. This is just a string that you can configure, a customized string. But many times we prefer to use the loopback IP of the remote router for ease identification. So I'll copy R1. So on R1, we paste this, quit. Then we do the same for. On R3, we are configuring two remote LDP sessions. We already have one. We don't need to 4.4.4, but we'll just configure it. On R3, quit. Then finally on R4, quit. So we can verify the LDP sessions again, display MPLS LDP session, that is the command, MPLS LDP session. So on R1, we now have a session to 3.3.3, which is a remote session. Can display MPLS LDP remote peer. You can see that we have one remote peer on this router. On R2, we haven't made any configuration changes. Remember, R2 is acting as the P router, and R1 is acting as a provider edge router. R3 is the boundary, so it could be acting as also a provider edge router. R4 is also acting as a provider edge router. So on R3, we expect display MPLS LDP remote peer. We have two peering sessions. And finally on R4, display MPLS LDP remote peer. We also have one session to 3.3.3.3 and the status is active. Label advertisement mode is set to downstream unsolicited. So that is the default mode of label distribution. So once we have done this, we go to the next stage of our configuration. We now need to do the Pseudowire configuration. We are now starting to configure our layer 2 VPN, and you can see that these are the configurations for R1. So we are using a VC ID, that is the virtual circuit ID of 100. If you use virtual circuit of ID of 100 on R1, you always have to maintain the same circuit ID on R4. So we have selected 100 as our virtual circuit ID. And then we do the MPLS L2VC. We are configuring a layer 2 VPN to 3.3.3. So 3.3.3, remember in this topology, so the setup for multi-segment, the setup for, let me take the back. So we are creating a layer 2 VPN from here to here, and then we are stitching. So it's kind of stitching from R3 to R4. So that's why when you check the configuration on this node, we are using the IP address of R3. And on R4, we'll be using the IP address of R3 also. So it's kind of multi-segment Pseudowire from R4 to R3, then from R3 to R1. Our switching point will be R3. So that's why we are pointing on 3.3.3.3. So I'll go back to the configurations. Select. So this is R1. R1, we do the configurations. Paste. Quit. Then we do similar configurations on this one is R4, not R1, just a typo. So on R4, we do similar configurations. Quit. You can use the command display MPLS L2VC brief. L2VC brief. You can see that we have LTBVC, we have one of them, and the AC status is up, the VC state is down. VC ID set 100, VC type is Ethernet, and the destination is 3.3. Link state is down. So the VC ID is down because we don't have end-to-end signaling from router 4 to router 1. On R1, we expect the same display MPLS L2VC brief. You can see that the VC ID set 100, the VC state is down, but the AC state is down because we have already bind a sub interface on these Pseudowire. So that's why the AC status is up, but the VC state is down because this one should be end to end. Can we see more details? We can be able to see more details, maybe like the uptime, the VC ID also, the VC type, the session state is up, remote VC label, you can see that it's still not set. A local VC label is set to 1027. So for us to be able to have this VC coming up, we need to do a switching on R3. So we need to configure MPLS L2VC switch command on R3 so that it can switch the Pseudowire that is running from R1 to R3. So I will copy this. On R3, I paste. So we have configured the MPLS L2VC switch, display MPLS L2VC. There is a command to check the switch. I don't know whether it's supported on MPLS L2VC. MPLS switch. Then we can check brief. So this one states that we have an MPLS L2VC switch configured on this router. You can see the status is up. So when we check now the status of our VC, we expect it to be up. You can see now the VC state was down, it's now up. On R1 we expect the same. It's down, it was down and it's now up. So our MPLS L2VC switch is now okay. And the final stage of our configuration is now to configure sub interfaces on C1 and C2 and verify that we can be able to communicate via the L2VPN. So I'll configure this name to C01, then interface gig 0/0/0. We are still using the VLAN of 100, VLAN type .eq100, and assign an IP address of 172.100.100.0. Mask is 31. So we'll do the same configuration on C2, system name C02, interface gig 0/0/0.100, VLAN type .eq100, assign an IP address of 172.100.100.1, mask is 31. So we can try to ping from C2 to C1, ping 172.100.100.0. You can see that we are able to ping. On R1, on C1 we expect the same. We can display ARP all. We are able to learn the MAC address from the far end. Try to ping 172.100.100.1. We are able to ping from C1 to C2. And given that this is a layer 2 VPN, if we try to do a packet capture, we'll not be able to capture any packets because they are carried transparently on our network. So I will filter ICMP, try to ping again from C1 to C2. You see that we are not able to capture any packets from C1 to C2. So this is how you can implement a layer 2 VPN on MPLS backbone, the Pseudowires or the VPWS, the virtual private wire service, and we are able to deploy services for multiple customers on our network. So thank you for watching. If you have enjoyed the session and you liked it, kindly hit that like button and also subscribe to our channel for more upcoming videos. Thank you.